everyone, welcome back to the Drawing Hub. So this is Python Programming Module 1 Part 7. And this is supposed to be the last video of this session of Module 1. Here, dot precision is optional. The next session shows the output of a floating point number without and then a format string. So we want the precision, we want 3 floating point numbers. That is why in this floating point I have written 0.3f. Okay, so 6.3f, so 3.14, so I get 3 floating point decimal. Next is lazy evaluation. When using any programming language, it is important to understand when expressions are evaluated. So I'm having a very simple expression, a equal to b equal to c equal to 5, and I have another variable d is equal to a plus b into c. Okay, now in Python, once these statements are evaluated, the calculation is immediately carried out. So in Python, once these statements are evaluated, the calculation is immediately carried out. Setting the value of d to 30. We do have the board mass rule. So b into c, 5 into 5, 25 plus 8. So that is 30. So you get the answer as 30. In other programming paradigms, such as in a pure functional programming language like the Haskell, the value of die might not be evaluated until it is actually used also. So if it is not used somewhere, it will not be printing. So only if it will be evaluated only if it is used somewhere. So the idea of differing computations in this way is what we call as the lazy evaluation. Python, on the other hand, is a very strict or eager language. Nearly all the time, computations and expressions are evaluated immediately. Even in the above simple expression, the result of b into c is computed as a separate step before adding it to a. Right? There are Python techniques, especially using iterators and generators, which can be used to achieve laziness. When performing very expensive computations which are only necessary, some of the time, this can be an important technique in data-intensive application. Next comes short circuit evaluation. So, short circuit evaluation, the Python virtual machine sometimes knows the value of a Boolean expression before it has evaluated all of its output. So the PVM will know the Boolean expression before it is actually evaluated. For instance, in the expressions A and B, if A is false, there is no need to evaluate B. Likewise, in the expression A or B, if A is true, there is no need to evaluate B. So if two conditions are given and we have to find which one is true. So A comes first and B comes second. Okay. Now A is already found as true. Then we don't have to come to B to check if it's true because A is already true. Only one of the conditions will be true, right? So this approach in which evaluation stops as soon as possible is called the short circuit evaluation. So I'm having count is equal to int input, enter the count. Sum equal to int input, I'm also entering the sum. So if count is greater than 0 and sum, its floor division is greater than 10, have to print the average of 10. Else, print count is equal to 0 or average is less than or equal to 0. That's a simple program. Now, operators. Operators are used to perform operations on variables and values. Python divides operators into, we have different operators like arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. 7 operators. Now, arithmetic operators: plus, minus, into, addition operator, subtraction operator, multiplication operator, division operator, modulus operator, exponent operator, integer division, floor division. So we have already gone through all this. Then comes assignment operator, that is the RHS set value is stored in the LHS. Equal to, plus equal to. So assignment operator, addition assignment operator, subtraction assignment operator, multiplication assignment operator, division assignment operator, modulus assignment operator, exponential assignment operator, and floor division assignment operator. Then we have the comparison operator. Comparison operators are used to compare values. It returns either true or false according to the situation. So less than, greater than, less than or equal to, greater than or equal to, not equal to. Okay. Next. Logical operators we have and or not. And returns true if both the statements we are having two statements, and if both the statements are true, we are using and. If both the statements are true, it will return. Or if we are having two statements and any one of them is right. That is all. Note, reverse the result returns false if the result is true. So if the answer is true, we will get it as false. That is not. Then identity operator is not. It is used to compare the object. Is returns true if both variables are the same. X is y. Or returns true if both variables are not the same object. X is not y. Like membership operator, used to test if a sequence is presented in an object. So we're having operator in and not in. In evaluates to true if it finds a variable in the specified sequence and false otherwise. Not in evaluates it true if it does not find the variable in the specified sequence and false otherwise. Then comes bitwise operator. Bitwise operators are used to compare binary numbers. We have bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift, right shift, and all. So bitwise AND, the ampersand symbol, and a bitwise OR, XOR, NOT is a tilde, and we have bitwise shift 2 lesser than, right shift, left shift is 2 less than, and right shift is 2 greater than. So this left shift and right shift, left shift will shift left by pushing in zeros from the right hand side, and right shift will be on the right side. Not, it will invert everything to bit. Now, types of bitwise operators. These are the types. Okay, so that is it about module 1. We will do further more programs on module 1 in the next video, in part 8. So till then,